So as this is a hangout, we'll just park all our questions, or we'll also have questions taken on Digvijay, or let me have all the ushers collecting the questions and let them give it to me, and I can ask questions on their behalf. Or you can also queue up out here and ask them question at the end of 45 minutes. So it's very simple, 45 minutes each session, followed by 15 minutes break. In totally a 1.5 hour session. Okay? So over to you, Tony and Anirudh.
Right. So, hi everyone. The topic for our talk today is what's new in Android. First of all, I would like to apologize that we couldn't be there in person. We would love to be there next time. Uh, I'm here in Hyderabad, and my name is Anirudh, and I'm part of the Android team. And we've also got Tony from Hong Kong.
Yes. Hi, everyone. Sorry we can't be here this time, but we hope we can see you guys in person next time.
All right, so we'll kick off the presentation. So the topic, like I said, is what's new in Android. The latest release of Android is the Jelly Bean. And one of the main objectives for us for this presentation, for this release, was to improve the UI experience and improve the continuity of the UI, to remove all the jank. And this is what we call as Project Butter. So it should be butter smooth. And a part of that is removing the jank. So what is jank? Jank is missing frames. So when you're actually going through some animations on the screen, or you're moving from an activity to another activity, you miss some frames, or you have some repeated frames. That means the same frame is displayed again because you were not ready, or the system was not ready to update the buffer to show you the next frame. And this causes discontinuous UI. And this is what we call as jank. Choppy frames and the inconsistent frame rate leads to a sort of incomplete or a sort of a bad user experience. And this is what we intended to improve and to remove all the jank in the system, and that's Project Butter. So first of all, I would like to introduce you to the concept of vsync. So vsync is basically a control signal that is sent to all the systems, or all the modules in the Android framework, to do so that all the processing and all the display and all the events that have to be processed, all the GPU and all the CPU stuff is done at a fixed interval of time. For the Nexus 7, the device is 60 FPS, which is 60 frames per second. So we send a control signal every 16 milliseconds, and everything in the system is synchronized to this. And this is called as vsync. So I will just explain you how things were before the vsync, or rather, we always had vsync, but not all the modules or all the GPU and CPU operations were synced to the vsync. So if you see this diagram there, you see a clock. You will see this regular intervals, which is a 16 millisecond interval, where you see the frame 0, 1 displayed. The green box is the GPU calculation, the GPU time. The CPU time is the blue box. So as you can see, CPU does its job, which is all the processing that it needs to do, and then it hands over the new screen, or the result of your on draw, to the GPU. And the GPU does its thing, and then there's the first interval is vsync, and we swap the buffer. So now we have the next screen, or the next frame, and this is the frame 1. Now, if you see this diagram, in the frame 1, you would see the CPU starts a little later because we didn't sync it before. This is pre-Jelly Bean. And then the graphic pipeline comes in, and that's the green box above. You see is cutting across the interval of the clock. Suppose you may have a lot of operations in your draw method, and that will result in a lot more time, and then you miss the clock. So what happens is you cannot refresh the frame because you've missed the clock of producing the output through the GPU. And this results in the same frame being displayed again. And this is what is jank. So when this happens at very frequent intervals, you will see sluttery UI, you will see jittery animations, and this is what we intended to improve. So now let's take a look at how how we achieve this with vsync. So now everything in the system, including CPU and GPU, is tied up to the clock. And in this same, it's kind of the same chart that you see here. You will see the CPU1, which is the first batch of CPU operations done, the first batch of GPU operations done, which is the green box. And then at the end of 16 milliseconds, or the end of, or at the vsync control signal, we swap the buffer, and now you have the next frame 1 being displayed because we finished our pipeline or our processing before that. And just as soon as you display the next frame, the operations for the next CPU, the CPU operations required for the next frame kick off. And this is what we mean by synchronizing everything to the vsync. And because we can kick it off right there, and the GPU takes more time, but still we are under the interval. And you will see that the next frame is again, after 1, we follow it up with 2. So you don't see the same frame again. Although the GPU in this case took a lot more time, but because we synced everything to vsync, everything fell into the pipeline or into the window where we could refresh the buffer. And I'm not saying this won't happen every time. So you may have lengthy operations in your Andra, you may be doing something, not optimized code, and you may miss it once in a while, but in general, the system performance will be much better. And so one more thing we introduced was triple buffering. Before I go on to triple buffering, let me explain you what is double buffering in terms of graphics pipeline. So again, the same kind of signal. You see the operations are the current frame being displayed, and that's the yellow bar on top. The current frame or the current buffer is A. And when A is being displayed, we are working on doing the operations to display the B buffer, which is our next buffer. So the CPU does its thing. Graphic pipelines take a little more time, the green box, and we could not swap the buffer because the graphics took a lot more time, and at the end of 16 milliseconds, which is your display refresh rate when your screen actually refreshes, and it's the same as the vsync control signal, we could not display the next buffer. Can we go to the previous slide, please? Yeah, so thank you. So we could not display the next buffer, so we show the same frame again, A, and this is jank. So you will see the same frame twice. But at this point of time, because we have only 2 buffers and this is double buffering, we just maintain 1 buffer on screen and 1 to process. Now we don't have a free buffer. We worked on B. B is ready to show. A is already on screen doing jank because of the jank. And we waste a lot of time now. You see the big interval in between in the second block. We are wasting all that time because we don't have a buffer to process. We are waiting for A to be freed up. And this is what is jank. So let's see how triple buffering in the next slide improves this. The same thing, but now you see we have a third buffer, which is C. And while there is time taken for B to complete, and we still have jank with A, we have another buffer C to process, and we can use this buffer to display next. And this improves the overall system performance and reduces the number of missed frames by introducing a third buffer, and this is triple buffering, which is now a part of Jelly Bean and improves the UI experience a lot more. If you've had a chance to play with Jelly Bean, you would notice it's much, much, much faster and fluid than ICS. So another thing that we did is the latency. We had a lot more latency with input, and again, we're going to do the same thing. Let's look at the old way of doing it, which is pre-Jelly Bean. As a developer, when you write apps, you have some input from the user, touch screens or gestures. The green bar that you see on top, the green strip, is actually a string of events that are coming from user. So it may be touch, it may be drag, it may be drop, and you see all these events. Once in a while, what we would do is batch them up together, and that's the blue block that you see. We've batched up the events A to C, and we've dispatched them. And finally, they reach the activity, which is your code, the CPU thread, and this is where we start processing A to C. Meanwhile, there are more events that are coming from UI, and we batch them in the next D to J, the second dispatcher blue block that you see. And while we are processing the first and we are drawing them on screen, we've already delayed the event D a lot of time because it missed the first batch, and now it's in the second batch, which will only be processed later. As you see in the activity, you see the second process, which is D to J. It's going to be processed much later. So yeah, this is a visualization of what's really happening. The input A event was processed at the end of first draw cycle. C was processed because it was in the first batch, but D took a significantly long time because it missed the first batch, and then it had to wait for the completion of second processing cycle to actually, or draw cycle, to have some result of the user. And this creates a lag on the screen. If you're dragging something on the screen, an icon, your finger may have moved ahead, but you would see that the icon is being dragged behind you, which is the same thing, the latency, because of the way we were doing it earlier with the dispatcher. Let's see how it improves in the new system, which is Jelly Bean. Again, you have a string of events, and what we did now is we got rid of the dispatcher. There is no dispatcher in the pipeline. So as soon as we are ready to process the activity in the activity thread, we have the CPU time. We will take all the events that have happened till then, and we will process them. We do not process the existing batch. We just process what is available till then. And this is all synced to the vsync. So this processing starts happening at the vsync control signal. And this process and draw cycle is the same thing that you saw in the first diagram as the CPU and GPU. The processing is CPU and the draw is GPU. So now let's look at the new latency. You see events A to F have been processed till the first draw cycle. We were able to do that because we didn't batch them till C. Although there is still an event G which has been delayed a bit, but the overall system, the overall latency is now low, and the UI is more responsive to user input. And this is something new that we did in Jelly Bean, and it shows up on the screen. It's very, very fluid. It's very, very smooth. All right, so
the next things I'm going to talk about is rich notifications. So Android is always, the strength of Android is, notification is always a strength of Android. And we make it even better in Jelly Bean. So here is a screenshot of what notification looks like in Jelly Bean. As you can see, like notification now can take up more height compared to the past. So, and another thing we brings in Jelly Beans is now as a developer, you can specify priority for notification. And before I mentioned about the expandable notification, on top of what we originally have a 64 dp height of the regular notification, we call it 1 unit. We now support something we call big content view, which we can show up to 4 units of notification, which is 256 dp. So here are some examples of rich notification. And one thing we bring it officially to the framework is what we call action buttons. In the past, you can create custom view to achieve the same effect, but now action button is a first-class citizen of the framework. So one use case of that is you can create notification which is highly interactive with the user for doing some like simple tasks. In this case, like you can directly call back a person or just do a +1 on notification without the user even going back to your application. Some good news, some bad news. The good news is in terms of icon guidelines, there's nothing changed since ice cream sandwich. And but one good feature from a user perspective is now user can now disable notification of a particular application. But that's the bright side is it does give developer better incentive to create less intrusive notification. So anyway, it's going to talk about SDK tools.
Yeah. So we're going to look at what's new in our tools now. So the first thing, we have an emulator with x86 virtualization, which means that on on the Intel x86 platform, you're gonna see some virtualization, which is gonna improve the performance. And so there is it's available with the 2.3 and 4.0 images of the emulator. Next slide, yeah. Now we also have GPU support for emulator, so there is a bridge between the system and the host, which is your computer, and we have graphics are being directly bridged to the host OS, and so this improves the performance of the UI significantly, because we've had hardware acceleration and stuff on UI, and the emulator for Honeycomb, when we started this, was really slow, and now we really improved this with the GPU support. It's much more fluid and very, very usable. We're now supporting OpenGL, EX 1.0 and 2.x standards, both with this GPU support. And like I said, the hardware acceleration support is also available. Another thing that's now available is sensor and multi-touch support. So you can use an Android device to send actual sensor and multi-touch events onto your emulator. As a developer, to increase your productivity, to increase your efficiency, and to help you write better code, we have the Lint tool available. Lint tool is context sensitive, it's always running, and it's able to give you advice and warnings and tips on what you are doing wrong, or a better way of doing what you've been doing. And these, you can look at these Lint warnings anytime, and you can go to the code and fix. And these are to help you improve your coding and to help you improve Android efficiency and performance of the apps that you write. We also have a tracer, which is utility to trace your method calls for OpenGL now, for the ESPEC. We have a device monitor, it's a new tool, and also a system trace. System trace is actually a pretty comprehensive and a very, very, very nice tool to find out problems in your system. So if your app is slow, if your app is janky, or if your list views are scrolling is kind of choppy, you can use system trace to find out where the time is being spent, and it gives you a very detailed view in an HTML5 output, and you can browse through those different bar graphs and charts to see where time is being taken by your system, and then go and fix those. We also have improved NDK support for building and debugging, and this is if you're using the native development kit, which is writing native C code directly to run on Android using NDK. You can now build and debug with our tools on Eclipse. There is also improved layout editor. So when you are designing your UIs by dragging and dropping controls, there's a much better layout editor, which supports different device configurations. So you can say, well, I have an Nexus 7 on layout in the night mode, landscape or portrait, and these kind of configurations. And so you can also now see your the changes that are going to happen when you change some configs across multiple configurations. So you can say, well, this language and this locale and this inch tablet form factor or this inch phone, and if you make a change, you can just see all the changes that are going to happen on all these different device configs. You can see them simultaneously in the plugin. Also, we have new property sheet to help you enable set properties. And this is really exciting. We have app templates now. So if you are new to Android, or even if you're experienced and you want to create a new Android application, once you start going through the wizard, we have an option now where you can use a template for activities. So if you look in the screenshot in the slide there, you will see that you can specify what kind of navigation type do you want, what kind of layout do you want. If you're targeting both phone and tablet, you can choose a multi-pane layout, and you can just generate the stuff using the UI. And this is a template for an app. So you can say, I need a news app, which is a list view and a detailed activity view, and you can just generate the entire UI stuff in the app from this. And we have improved XML formatting and some performance tools.
Okay, so the next topic I want to talk about is building Android apps using web APIs. So we understand not all applications have storing all the content in local storage. So we have a solution for you guys now. We launched this Google Cloud Endpoints back in Google I/O 2012 in June. And so what that does is like it allows you to create REST API very easily in an App Engine. So on App Engine, you just need to define some entities, and by doing some annotation, you can expose your entities like through a whole bunch of like REST API. It's very easy to do. Another thing is coming soon is what we call Google Play Service. So it's a separate APK from us, and allows you to do like things like OAuth integration. So for those who have done like OAuth authentication, will definitely agree it's not a very easy implementation. So we want to make it easy for developers, and that's why we include like OAuth 2 support in the Google Play service. And also when we launched Google Play service, we will have new Google Plus APIs come with it. Another things we improve is what we used to call C2DM. Now we rebranded to Google Cloud Messaging. So good news is it's still free, and also now we have unlimited quota. Another new feature from Cloud Messaging is now we support some sort of multicasting. So in the past, if you want to reach out to all the phone install your application, you have to make many requests. So now you can batch requests and send 1,000 messages per single request. Another improvement of Cloud Messaging is in the past we don't support payload, and we don't recommend people using Cloud Messaging with payload. But now we do support it now with you can send up to 4 kilobytes of data. So anyway.
Right. So now let's apart from the tools and the web API support and the project builder, let's see what's more new with the user interface. So what we've got is activity animations, and there's a new helper class, activity options, which can help you create your own and control the animations that happen on activity transitions. And you can specify points or rectangles from where to kick off animations. For example, when you request a new zoom, you can choose a certain area in your rectangle area in your activation in your activity, and the animation will start from there. And you can optionally include bitmaps for thumbnails, and these are some of the customizable options with activity animations now. We also have widgets that can respond now to size changes, so you can resize them, and if you're moving them around, they can respond to the changes that happen and refresh their views. We also have certain performance improvements with text views and a simplified backstack navigation behavior. We introduced this pattern of up navigation starting honeycomb, and so now we've really simplified on navigation, what it really means to go back in the activity stack, which is going from an activity to the previous activity that led to this activity, or going up the hierarchy. So if you're in a shop or in a commerce application like one of those eBay or Amazon or one of those apps, and you are in a category, say books, and you're going through some fictional books, using the up navigation, you can go back to a bigger category, up the hierarchy of the application, or go up the data chain. And so with this, we've simplified the navigation, and this is a significant improvement with user interface and how a user feels when using the system. We have a new storage permission, and this is when you use the external storage. The permission is android.permission.read external storage, so that the users are aware that a developer, an app is trying to access. This is not really enforced right now because we want to give you a chance to adapt your application. So we highly recommend that if you are using reading external storage in your apps, you include this permission in your manifest to be compatible with the new guidelines. Also with Android Beam, you can now do large transfers via Bluetooth. You can use Android Beam to trigger off a Bluetooth connection and then move huge files over the Bluetooth data.
So talking about Nexus, so one thing, of course, everyone probably already know is we introduced Jelly Bean back in June, and now it's available in all the device in the Nexus line, including Nexus 7, Galaxy Nexus, Nexus S, and the Motorola Zoom. Another good news is Jelly Bean is already open source, so feel free to check it out in the AOSP website. So this is Nexus 7, and it's available in a few countries right now, and we are in US and I think Australia and some other country. Hopefully we can bring this to more countries very soon. Some advice on developing Android application for Nexus 7. So when you building your apps and want to target a 7-inch tablet, so one thing in the resource bundle you want to make sure you understand is to use the smallest width qualifier. The magic number is really the SW600 DP, and this is how we target the 7-inch tablet. So for regular handset, you can use the regular layout folder, and for 10 inches tablets, you use the SW720 EP qualifier. So I think that's pretty much what we have today, and this is this page is I hope most of you guys are already familiar with our Google Plus page for Android developers. So you can go there by visiting Android developers. And one thing I want to remind people is we now have office hours in APAC. So so that means we call it Android Developer Lab Plus, and it's really a hangout, a regular hangout every week. We format the hangout a little bit, starting from the last two hangout. The format is now more like we have a short presentation, like 10-15 minutes, and then we share some what's new in the Android ecosystem. And then we, of course, as usual, like answer questions from you guys through moderator. It's happened every Thursday, 11 a.m. IST time, and so that means like tomorrow we have another session. So anything you want to add?
Yeah, I mean, you guys, if you go over through some of the Nexus 7 development stuff that Tony covered, and if you have any questions, do note them out. We have a moderator link. So if you visit our Plus page, you will see an entry to the event. And we've linked the moderator page where you can ask us questions ahead of time. And we're going to take up those questions during our office hours. And we also have some presentations. And I believe the topic for tomorrow is density independent pixels, DP. And Tony will be doing that presentation. So if you want to know more about that, please do join us for the hangout.
Yeah, that's a really important topic. I think like even very seasoned developer always got kind of confused, like how to use DP, and I think we would like to clarify and also share our thoughts with you guys. So if you have a chance tomorrow, just join our hangout.
All right, so I think we now open up for questions. So you can walk up and ask questions if you like. Yes, Sunil.
Yeah. So if you got any questions, just walk up to this place and just queue up for the questions. Yeah, just come over. So just queue up for the questions, yeah. So we'll be taking around 5 or 6 questions.
Can we configure it with VS 2010? We can use an editor like 2010 VS.
Yeah, you have to be louder.
Can we configure it with VS 2010 as an editor?
Are you able to hear, Anirudh? Can you edit with VS 2010?
Can you edit with VS 2010?
As
well,
editor?
The language. So I'll just repeat it if I got this right. You said, can you edit files with VS 2010, the Visual Studio 2010? No, we have a very specific plugin that works with layout libraries. So we have it for Eclipse, and there is some support available for IntelliJ. But that's pretty much the idea. You'll have to use if you want to use some of the tools and the layout editors and the stuff we've been doing. And moreover, it's a Java programming language, so more suited with Eclipse and IntelliJ.
Hi. So my question is why mobile devices manufacturers...
Can you speak louder?
Yeah, why mobile manufacturers are not pushed for earlier upgrades? Because I've seen even Motorola is not having upgrades on the older devices like Defy. So even after acquisition of Google, they are still on like 2.2 or 2.3. So why they are not pushed to the earlier upgrades which are coming like ICS and Jelly Bean? Yeah.
I've not been able to hear you very clearly. Sunil, if you can repeat that question in a different mic.
Yeah, why are the device manufacturers not forced to upgrade to the latest version of the devices?
Okay, so I think in the end it's really up to the manufacturer, and it's not just manufacturers. There are carriers and how they want to test the new builds, and before they deploy, there are some carrier-specific things in the bill, and so it's really up to the carrier. We do have programs on compatibility test suite and how we want to see the builds being pushed out, but it's really there are a lot of stakeholders there that want to test the system, and then have their preferences over which region they want to roll out, and it's not like a global rollout altogether. Some carriers and manufacturers prefer, sending OTAs to a region, North America or EMEA, before they send out to other regions. So it's more of a business decision there, I would say. Tony, do you have anything to add?
No, I think what you said is accurate, and we always work with the carrier to try to help them to accelerate the push. But again, there are a lot of additional things they need to test, or they have like prepackaged packages like applications, and so it's more than just like testing the OS itself. So. Yeah.
Okay, cool. So here's the next question. Most developers use Eclipse as an IDE. Is there any benefit of Eclipse, or what if I'm very comfortable using MetBeans?
I would say with Eclipse, our tool teams work on creating the plugins necessary, and with Eclipse, that's the first IDE targeted in terms of the new features of plugins. There is really nothing that should stop you from using any other IDE, but some of the stuff that is available in the plugin, which is the layout editor and the drag and drop stuff, will not be available. I personally use IntelliJ. I use Eclipse as well, and I use IntelliJ, and so it's really your choice. It's just that some of the stuff is available in Eclipse before others.
Yeah, we have people even using VI and then running NScript, right? So it's really up to your choice of IDE.
Okay, and here's the next question. How to optimize cross-platform HTML5 apps developed over third-party APIs like PhoneGap?
PhoneGap. How do you? So let me repeat the question. It is, how do you optimize cross-platform HTML5 apps which use third-party frameworks like PhoneGap, right?
Yes.
Right, so I'll take it up. So we have a lot of performance tools available for native applications. That's the code that's running on Android. In terms of HTML5 apps and PhoneGap is kind of proprietary, so we don't really have any insight on what they do. And so if you want any tools, you will have to contact them and what they offer for performance and how they translate code. And it's really kind of proprietary, so we don't have much insight into what PhoneGap does. There are some standard generic HTML5 tools for performance, and yeah.
Yeah, I just want to add a comment. So when you consider when you design your application and have the choice of like going HTML5 and or native application, I think one thing you need to consider is what's your target audience and what kind of application you're building. I mean, for example, if you are building an application that rely heavily on the phone's sensors or some device capability, so maybe it's a better option to go for a native application. But on the other hand, if you already have a website or a mobile website, you want to immediately leverage what you have. So that maybe HTML5 approach may be better for you. In terms of using third-party products like PhoneGap, so one thing you need to keep in mind is you are adding an additional layer of a dependency of other third-party developer. It may be a good thing. I mean, if the developer do a decent job on updating their framework, but at the same time, if they are not doing a good job, then you will suffer on their bug or lack of feature not in sync with the latest SDK. So that's something you want to keep in mind.
Okay, here's the next one. Can all devices currently in market run on all versions of Android, or is there any specific hardware requirement? And will the Google Glass be integrated with Android?
We didn't get the second part of the question.
Will the Google Glass be integrated with Android?
Google, is that Google Glass?
Yeah, Google Glass.
Okay. So I'll take up the first one. There are many different hardware platforms available. For example, there are Snapdragon chipsets and Qualcomm. From Qualcomm, there are ARM chipsets, there are Cortex. It's really a thing that a vendor has to do, is to provide compatibility for the low-level stuff on their platform or for their chipset. Android as such does not have any kind of hardware minimum specifications, but you obviously running something like Jelly Bean or ICS, which has a hardware acceleration, requires for a better UI experience, requires you to have a powerful smartphone, sort of powerful. But there are no really specific hardware requirements, and if the vendors are bringing in the modules to for their chipsets and for their drivers, that's all good. That should work, right, Tony?
Yeah. So another thing is that's kind of exactly what we want. What we did for Jelly Bean is to improve the performance and make this particular release more lightweight. So we see even actually some devices couldn't even run ICS before, can now run on Jelly Bean. So we are working hard to get the OS more lightweight as much as we can.
And the second one of the question, we are actually not much aware of what's going on with Google Glass in the team. The developer program is yet to open, and there were some announcements in I/O regarding that, but I do not have any information on the architecture and deployment strategies there.
Yeah.
Okay, so it's still in very early stages in terms of Google Glass, so we usually do not take questions related to that in these forums. And here's the next question. How is Android fighting the problem of its own fragmentation? Why do apps still take way longer to turn up on Android than when compared to iOS?
So anyway, you want to take the first step, or you?
The fragmentation, right? I mean, well, with ICS launch, it was a big step towards creating a unified operating system. We went for a tablet operating system with Honeycomb, but that was just meant for the tablet release. With ICS, we have an OS that runs on all devices alike, and we write new features in new versions and provide them using support library so that you can use them on in a backward compatible fashion. So you can use them on older devices. For example, with our support library, you can now use fragments on even 1.6. So, and with as a developer, you can write an app using the support library, which would use the new features on newer devices and will be able to use the new features on older devices with just the compat library, the support library. So things are much better now, and yeah, I mean that's all I have to say about fragmentation.
Yeah. So another thing is also one thing unique about Android ecosystem is we do have like yeah. Anyway, did you say something?
Yeah,
can you hear me?
Yeah, we can.
Okay. So one thing very unique about the Android platform is we do have many different devices of different form factors. So one way to address this is to have the resource bundle to allow developer to define different access and layouts to accommodate the needs of like all these different devices. It's going to be more work because as by definition you're writing an application to support many devices, but it can be done. And if there's anything in the framework that doesn't address your need or you run into problem, we are happy to hear that and try to fix these things.
Okay, here's the next one. Why isn't Google Chrome released in a stable version for Android yet? It crashes pretty frequently.
Well, sorry, the question was why?
Why isn't Google Chrome released in a stable version for Android?
Right. So I think the version is pretty stable. We did a maintenance when we launched and not available internationally. Maybe I missed something in the question there.
Well, one thing about like Chrome is Chrome working on browser and working on a desktop PC is are different things, right? I mean the phones and the regular desktop have different capability and performance like things need to be considered. So we for web view, like we don't have all the CSS or HTML5 feature enabled, but the team is working hard on bringing all these things you have on the desktop version to mobile. But it's just a matter of time, and it takes more time and effort to optimize on the mobile platform.
Okay. So is in Jelly Beans, most changes that you mentioned is on the display side. Are there any changes for power optimization?
I don't get the question.
Is there any improvement on the power optimization side in Jelly Bean?
Any improvement on which side? Sorry.
Power optimization. Battery power optimization.
Yes, there is constant ongoing work across all components. When I said we worked on Project Butter, that doesn't mean we didn't work on any other stuff. There are obviously the Dalvik or the VM team is working on the different kernel modules and how to optimize the system. With Jelly Bean graphic driver pipeline, we've kind of optimized there. So there is definitely an improvement. I mean, I don't have benchmark numbers with me, but I've used Galaxy Nexus with ICS and with Jelly Bean, and I find the performance actually much better than ICS.
Okay. Yep. Here's the last one. Are Indian languages supported on Jelly Bean?
Sorry, which libraries?
No, are Indian languages supported on Jelly Bean?
Didn't get it.
Sorry, in Indian languages.
Indian languages. Yes, with Jelly Bean there's more support, and even some of the stuff like Google Now and Voice, there is more support there for Indian dialects of languages with the English Indian dialect. And, yes, there's increasing support, and we're not saying we've reached where we want to. We still have work to do, and hopefully in upcoming versions we'll have complete feature support there.
Yeah, I also remember we have better right to left language support as well. So.
Yeah.
Okay, thanks a lot. So let's give it up for Tony and Anirudh, guys, for his first sessions. So we have got another 20 or 30 related questions. So Anirudh, can you just let them know once again, how can they post their queries for all the questions? We have got another 30 more questions.
Right, so Tony, if you can share the screen for...
Sure.
Right. So Tony is going to put up a screen in front of you, which is a link to our Android developers page.
Is it this one?
The one before this.
Okay.
So this is the Hangout that, this is the page, Android developers. So if you go to Google Plus and you go to Android developers page, you will see our Android Developer Lab event from APAC. You see Android Developer Office Hours there, and just look for the APAC one, and it has a link to a moderator. Hit that link. Moderator is our question answer system. You can enter questions. There are already some questions. You can kind of add more or vote up or vote down the questions if you want to. So that will be, and if you do it today, we'll probably be able to get to them tomorrow.
Okay. Yeah, and also you can always add me or Anirudh in Google Plus, and we're happy to follow up questions with you guys.
Cool. So it makes sense. So Anirudh and Tony, so we'll have a 15 minutes break, but can you just give a sneak preview to the audience as to what you'll be doing after this break? What sessions will you be covering?
So we are going to talk about design, and of course, like Android UI design, and we also will share some tips